I've got several cards here, a motherboard, and some drives that I need to photograph. And I figured this would be a good opportunity to talk about some of the best ways to take high quality photos of PC components like these, or really any electronics device. I try to photograph every board and device in the serial ports collection. They're super handy to have for reference, and I'll also submit them to the RetroWeb if they happen to be missing there. And having high quality images is important so that you can see component markings, signs of damage prior to repairing, and just for history's sake. It's important as well for rare items that may have never been photographed ever before. But PCBs are surprisingly difficult to photograph well. The RetroWeb has a general guide about photo quality, which does a good job of showing where problems can come up. And if we check out their example of the best quality, we can see what they point out. Most, if not all, of the text on the board is legible. So if someone had this board that had a missing component, like a resistor for example, they'd be able to source the correct value based on this photo. On the good quality example, initially it looks pretty good, but on closer inspection, we can see where it's lacking. We can see some areas are shadowed, especially the components between the ISA slots, and there's also some blurring at the edges of the board that makes some of the text a little harder to read, though not impossible. And the acceptable quality photo is pretty bad. The resolution is low, the lighting is uneven, and aside from the major components, it's basically impossible to make anything else out. For sharp, high-resolution photographs, it obviously helps to have a nice camera with an adjustable shutter, aperture, and so on. Any digital camera produced in the last decade at least should have this ability. And smartphones can work too. You can still get excellent results from just a smartphone camera with a few tricks. By far the most important point is lighting. Solder mask on a PCB tends to be pretty reflective, which means it's easy to get glare and bright spots, which make for a poor photo. This means using the flash on your camera is no good. What works best is a soft light, which is light that has been diffused in some way. And it helps to have at least two sources of light to avoid shadows. I have studio lights for our work on the serial port, so I tend to use those when taking photos. I have one on either side of this table. I set the color temp around 5600K, and then move the position of the board to get the best photo with the least shadow and glare. Even a cheap set of LED panel lights would probably do the trick, but let's look at some other sources as well. Using natural light from a window can work if you have blinds or a lighter colored curtain to diffuse the light. But see how the board is darker towards the bottom of the image? If we set up a small lamp behind it, that fills in and makes the photo much better. Overhead fluorescents are good for overall light coverage, but it can be tricky to avoid reflections. If I move the table back a bit, I get less of a reflection, but now with a glare at the top of the board. If I stand on the other side of the table and add a lamp, I still get a little bit of glare. But almost any light can be diffused with a white bedsheet, and that instantly improves the result. And I took this shot with 3 lamps on the table with my smartphone. It's certainly not perfect, with some blurring around the edges and some areas are obscured, and you can't read the smallest resistor values. The lighting is fairly even though, which is impressive for just using some random lamps from around the house. If you really wanted to solve the issue or get the highest quality possible, you could use something like a Lightbox. Dave over at EEV blog has a 2-part series on how he built his own DIY Lightbox, and it turned out really well. The background of what you're photographing is important as well. It's best to avoid anything too textured or patterned. If possible, you want a very neutral background like this white table. And if you don't have that, try a plain bedsheet over whatever you're using. The point is to make the background as neutral and plain as possible to make the photograph easier to look at. With the lighting and background taken care of, the next step is to set up your camera. Sometimes I'll shoot things freehand, but other times I'll use this articulating arm that clamps onto the table. These can be pretty inexpensive, especially if you're using a smartphone, but you'll want something more stout if you're using a heavier camera like this one. This, for example, is from Elgato, and with my heavier camera, it has a hard time maintaining the height I want. For camera settings, one of the most important is metering, which controls your camera's shutter, aperture, and/or ISO. Most cameras sample multiple parts of an image to determine those values, but that's problematic if you're shooting a dark object against a bright white background. The background will cause the camera to try to avoid washing out that background too much, which in turn makes the subject too dark. To avoid this, you can use something called spot metering, which most cameras support, which just samples the center of the image to determine metering. On a smartphone, simply touch the center of the device on your smartphone screen, and then you can adjust it from there. Or even tap and hold, and it will lock the exposure to what you selected. The more advanced step is to set the shutter, aperture, and ISO manually. This is mainly applicable to cameras like these. There are smartphone apps that give you more granular control over the camera, but you usually won't be able to adjust the shutter or aperture. In general, though, you want a decently fast shutter speed to reduce blur, especially if shooting handheld. The conventional rule is to match the focal length of your lens measured in millimeters, but I typically aim for around 1/125. A lower shutter speed is more noticeable on smaller boards where you might need to zoom in with your lens. For aperture, the lower settings increase the amount of light that can enter the lens, which is good, but at the trade-off of depth of field, which is how much depth of the subject can be in focus. In other words, a very shallow depth of field, which means a lower aperture value, won't be able to focus both the board itself and the top of these PCI slots, for example. If we increase the aperture value, these features are now in focus, but we get less light into the lens, so we have to compensate by either lowering the shutter speed or adjusting the ISO value higher. The ISO controls the sensitivity of the camera sensor, or in other words, how sensitive it is to light. The higher an ISO, the faster our shutter can be, and the higher our aperture, both which are good for this type of photography. But of course, there's always a trade-off. The higher ISO means higher noise. Compare these two photos, one shot at ISO 250 and the other at ISO 2000. You can make out the model number of the Realtek chip pretty easily at ISO 250, but the resolution suffers at the higher ISO. So going manual can get you really good results, especially if your camera is having problems determining the values automatically. But it takes a lot of experimentation to figure out the right combination, and it's heavily dependent on your camera, the lens, and the environment you're shooting in. So again, don't be afraid to experiment, take a ton of photos, and figure out which combination looks best. For me, I typically leave ISO on automatic and set my shutter speed and aperture manually. The reason is that if you've got enough lighting and a decent camera, the ISO should be within an acceptable range automatically. But that may not be the case for all cameras, so again, try some different settings and see what works. Now for the actual photography. Orient the board on the table so that it fills up as much of the viewfinder as possible. So for this motherboard, I'll actually turn it sideways. From there, I'll move the camera as close to the device as possible while still being able to focus. As the closer you are, the more details will resolve. For smaller cards, I'll zoom in with my lens if need be to get as close as possible while still capturing the entire board. I'll take shots of the front, back, and I/O ports. Some boards won't lay flat, so sometimes I'll use something to prop it up to make it level. For any type of drive, I'll take photos of the top, bottom, front, and rear. The white labels or reflective surfaces on some drives can definitely mess up the metering of your camera, so those may take some extra adjustment. I tend to take a few photos of each position, and once I'm done shooting, I'll load them onto my PC and into pretty much any photo editor. I zoom to 100% and see which ones look best in terms of lighting, sharpness, and composition. Once I know which ones I want to keep, I'll crop the images down to eliminate as much of the background as possible, but making sure not to crop out any part of the device, obviously. From there, simply save to the format of your choice, and it's done. From here, I usually submit them to the RetroWeb if they're missing or better than the photos currently on there for a component, like this motherboard, for example. And that's it. I find the process of doing this kind of fun and addictive in its own way. And it's also just really practical. You can take high quality photos of a board before repairing it as a record of how something looked. Or if you need to reference something on the board, like figuring out what chipset it used, it can be a lot easier to look at a photo than trying to find the board in storage. Hopefully this was helpful to someone out there, and I'd really love to hear how other people get high quality photos of their gear. So please leave a comment if you've got any of your own tips. Thanks for watching, and I'll see you next time.